This is my favorite episode. We're gonna play a game and have some fun. I want to show you something very exciting, so just follow me. Come on, let's go this way. This way, around the table, let's go. Okay. What we see here is a setup for the most popular game amongst students in the United States. You know how it's called, but if you don't, I'll explain the rules in just a moment. And this is proof that we really had Sprite in these red cups. Player number 1 throws a ping pong ball, and if the ball goes into the red cup, player number 2 will drink the content of that cup. And then vice versa. Player number 2 will take the ping pong balls and try to throw them into the cup. And if they manage to do so, player number 1 will have to drink the content of it. What's important for this game and our purpose, learning R, is that I have 6 ping pong balls in my hands, player number 1, and I will try to throw these 6 ping pong balls into the red cups. And just keep in mind, these red cups are in a matrix form, a 4x4 matrix. I have 4 columns and 4 rows in my matrix, a total of 16 red cups filled with liquid. All right, what I'm going to do now is I'm going to step 3 feet away from the table and try to make Carolina drink one of these cups. Ball number 1, fingers crossed. You're drinking! You're drinking, you're drinking. There you go. Ball number 2. Oh no, I've missed. Ball number 3. Yes! Okay, you're drinking again. There you go. And again. Yes! Wow, you're drinking a lot. Enjoy it. Oh, missed that one. And the last one. Ah, that one was missed too. Okay. So in this exercise, I was able to throw 3 balls into 3 cups, and 3 balls were missed. So Carolina got to drink Sprite. That's her favorite drink, Sprite, from 3 different cups. Let's take a look at which cups she had won. Let's take a look at which cups she won. She won the cup from column number 1, row number 2, this cup. She also won the cup from column number 2 and row number 2. And she also won the cup from column number 4, row number 3. In this game, there are at least 2 random processes. The first thing is that when we throw the ping pong ball, we don't really know if it's going to hit into the cup. That's the first random thing. The second random thing is that we don't really know which cup the ball will fall into. It could be this cup, it could be this cup, it could be this cup. And the real question is, can we create a similar game in R using code? Loops are used to run the same chunk of code multiple times. So let's loop through our data. We had 6 ping pong balls labeled 1, 2, 3, 4, 5, and 6. For the first ball, we'll run our code from the loop body, and our I index that represents the ith ball will have a value of 1. For the second ball, we'll run our code from the body, and the I index will have a value of 2. For the third ball, same thing. We'll run our code from the body of the loop, and the I index will have a value of 3. Same thing for the fourth ball. We'll simply use I equals 4. Again, same thing for the fifth ball. We'll have I equals 5. And finally, for the sixth ping pong ball, the I index will have a value of 6. We played a very exciting and interesting game. And now the real question is, how can we code that game in R? Is there a way for us to recreate the rules and the outcomes with code? And the answer is yes, with for loops, right? What are for loops? For loops are functions that repeat a block of code, a body of code, multiple times, okay? And everything will make sense in just a few minutes. Let's start by putting in our for loop template into our studio. Let's open up our studio, and I'm going to start with a new script by saying for. That's how every for loop starts, with the word for. And I'll open parentheses. The parentheses define my header, my index. Okay, how many times will my for loop run? What do I want to put into each iteration of my for loop? Right? In this case, my for loop will go over 6 times for 6 balls that I threw independently. So I'm going to denote the number of my ball with the I index. I in 1 through 6. So my ith ball was thrown at the cups. Now, the I will be replaced with a number 1, 2, 3, 4, 5, and 6 for all consecutive 6 balls. Now, we've defined how many times the for loop runs, but we also have to provide the body of code that will run each time for each ball. Right? And I'm going to do it with the French braces or curly brackets. I've heard both names for it. And this is where I would put the block of code to submit. Good coding practice, always write a comment, hashtag closing the I loop. Because you'll have multiple loops in your code, you'll have nested loops, and it's always better to know which loop you are closing. You'll have a lot of these brackets, sometimes 2 or 3, and it's good to know which one is closing which loop. Let's go back to our body. In our body, what we'll do is we'll basically ask R to randomly tell us whether the ball went into a cup or not. Okay, so it's a binary decision. 1 if the ball went into a cup, and 0 if the ball did not. 1 for success, 0 for failure. Right? I'm going to write a sample function. I'm going to sample from a very basic vector with 2 elements, 1 and 0. 1, 0. Right? R will tell me if the ball went into a cup or not. Now, the second argument for this function is called size. And the size should be equal to 1, because I'm throwing 1 ball at a time. If I had 3 balls and threw 3 balls simultaneously, then my sample size would be 3. Okay, but I was only throwing 1 at a time, so sample size equal 1. I'm going to save this result, this success or failure, 1 or 0, in an object called my_result, reverse arrow. My_result, reverse arrow, sample from a 1, 0 binary vector. Now I want to see what the result was. So I'm going to use the print function to print my_result. I'm expecting from this for loop to give me 6 answers, 6 digits, 1, 0, 1, 0, 0, 1, 0, 0, 1, 1. Okay, 6 of them. If I select this for loop and hit Command, Return, Control, Enter, I'm going to get 6 numbers. Wow! In this case, if I go to my console, at the bottom, I will see that the first ball was a success. So 1 represented that the ball went into the cup. So the first one went into the cup. The second one as well. The third one as well. The fourth one as well. All 6 balls went into a cup. Amazing. Wow, such a great run. If I run this loop once again, I'll get different results. Okay, the first 4 balls went into a cup, but the 5th one missed. The 5th ball missed. And the 6th one went back into a cup. If I run this for loop once again, I might get even different results. Now, 3 balls. Number 1, ball number 3, ball number 5 went into a cup, and ball number 2, number 4, and number 6 did not. Okay? It's a random process, just like my throwing. Understand the structure of an if statement. The main component is our condition, if this statement is true. There would be a logical test that should result in a true or false answer. A few examples are, if value in a vector ith element is equal 100, then true. If my df ith row zth column greater than 20. If names equals Zoe. The second if statement component is called the then statement. It executes code if the condition is true. We put it in curly brackets. We can end our if statement here or make it more advanced. To make our if statement more advanced, we'll use the then statement and the else statement. Just like the then statement executes code if our condition is true, the else statement executes if our condition is false, not true. Can we improve this for loop to better represent our game? What we have so far is great because we can answer the first question. Did my table tennis ball go into the cup or not, right? But the second question, which is more important, would be how much liquid was in the cup in which the ball went into, all right? In order to improve this for loop and answer that ultimate question, we have to design a matrix with the amount of liquid in each cup. Remember, our cups were formed in a matrix, 4 rows and 4 columns, 16 cups totals. What I'm going to do now is I'm going to create a vector and come up with 16 different amounts of liquid. So let's go here to our R code, move this forward a little bit down, and at the top of this code, I'm going to say liquid. I'm going to create a new object called liquid, reverse arrow, and C, my function that creates a vector. And in this vector, I'm going to provide 16 different numbers that represent the liquid, the volume of liquid in my 16 cups. 0.1, comma, 0.2, comma, 0.3, comma, 0.4, first row of my cups, comma, 0.12, 0.13, comma, 0.14, comma, 0.15, comma, 0.20, comma, 0.21, comma, 0.13, comma, 0.15, comma, and last 4 cups, 0.09, comma, 0.08, comma, 0.12, comma, 0.14. Okay, 16 elements in my vector. And if I select this and click Command Return or Control Enter, I'm going to get a large vector called liquid with numbers in it, 16 elements. With random numbers, they can be whatever, you can make it up as well. All right, so now what I'm going to do is I'm going to convert this vector into a matrix. Remember, 4 rows and 4 columns. My underscore liquid underscore matrix, reverse arrow, and I'm going to use the matrix function to take the liquid vector and put it into n row equals 4 and n col equals 4. 4 rows and 4 columns. Command return. Okay, and I have a data object, a matrix, numerical matrix, 4 rows and 4 columns. If I double click on my liquid matrix, I'll see what it looks like. Beautiful. It just looks like our 16 cups on the table. And now, what I can actually do is make the following statement. If the ball goes into a cup, meaning my sample is equal 1, then I will select a random cup. I'm going to say, we don't really have a pattern here, it's at random. So when I throw the ball, it's any cup. Okay? So I'm going to make some space in the body of my for loop, and I'm going to say if, an if statement. The condition for this if statement is the following. If my underscore result equals 1. So the condition here is that the ball went into a cup. I don't want to know what happened if the ball did not go into a cup. I want to know what the liquid was if the ball went into a cup. Makes sense, right? Okay. So if my result equal 1, then, French braces, what I want to do is I want to sample, again, sample from my underscore liquid underscore matrix. And the sample size should be 1. 1 cup. 1 ball, 1 cup. If the ball goes into the cup, my if statement, right? Okay. Now the else, what happens if the ball does not go into a cup? Meaning my underscore result was 0. What happens then? Well, else 0. Fair enough, okay? And I want to save the amount of the liquid in a new object. I'm going to call it liquid underscore amount, reverse arrow. And I want to do the same for the failure case, else liquid amount, reverse arrow 0. Okay, so once again, let's read this if statement. If my underscore result is 1, meaning the ball went into a cup, please select a random cup from the liquid matrix and save the liquid amount, the number, in the liquid amount object. If it did not go into a cup, then the liquid amount is going to be equal 0. Okay? And now I want to print my underscore result. I actually made a typo in my previous for loop. So the second print statement should be print liquid amount. I want to print my result, the success or failure, and then print the amount of liquid that I'm getting from that cup. So let's run this for loop. I'm going to select this and do command return or control enter. So here's what I'm getting. For the first ball that I throw, it went away. It didn't go in. So the amount of liquid is 0. For the second ball that I throw, again, it missed the cups. So I'm getting 0 liquid. The same thing for the third ball, same thing for the fourth ball. But luckily, the fifth ball went in. 1, which means success. It went into a cup. And the amount of liquid is 0.09. Okay. The sixth ball did the same. It went into a cup, and the amount of liquid is 0.2. However, what I can do now is sum all the liquid amounts to see what the total amount of liquid is that my opponent had to drink. Okay. In order to do so, what I have to do is save the liquid amount in a vector, in a new element in a vector. So what I will do is I will say that I want to save the results, the liquid underscore amount, in an object called all liquid reverse arrow. But what I have to do now, and here's where I'm going to use the I index. I'm going to indicate that I'm going to save this in the ith element. Okay, so my all underscore liquid will have 6 elements with results of the liquid amount. Okay, the first time this for loop runs, it's going to save the data inside the all underscore liquid object. The second time it runs, it's going to save the liquid in the second element of my vector. Okay? Before I run this, it's a very, very good practice to actually create an empty object. All underscore liquid, reverse arrow, and then C with empty parentheses. Very good practice. This is going to be extremely helpful when we move into data frames. Okay? So don't forget to run this and create an empty vector called all underscore liquid. As you can see, all underscore liquid is empty right now, but our for loop will put data into this vector. 6 elements, because I run the for loop 6 times. All right, so let's just submit this code, command return control enter. And it seems like 3 first balls went in, then 2 balls did not go in, and the last ball went in. So 4 balls that went into cups. And if we actually take a look at the all liquid vector that has 6 elements, numeric, the first liquid amount was 0.13, second liquid amount was 0.3, then 0.12, 0 and 0 because the fourth and the fifth ball went away, and 0.15 for the sixth ball. To answer the ultimate question, which was how much liquid did my opponent drink in totals, all I have to do now is add one more statement that will sum all the elements in my all underscore liquid vector. If I run command return control enter, the sum of all the liquid is 0.7. Could be liters, could be milliliters, could be ounces, whatever, right? But this is the sum of all the liquid my opponent had consumed. So this is exactly how I would code our game, our very popular US college game. And to insert data into an object using for loops, we'll create the for loop for 6 balls and create an empty object, data frame in this case. When running the first loop, the code will use the ith index to point to the first row or first column. When running the loop the second time, the code will use the ith index to point to the second row. The same will happen with the third index, with the fourth index, with the fifth index, and with the sixth index. Let's do one more example. I'm going to go back to my script and data from episode 3 with my roommates and their salaries and the dates and the names, and submit that data frame, okay? And run a for loop to identify specific elements. So I'm going to go back to my script from episode 3 and submit all these vectors, names and all the salaries. I'm going to then create the dates, create the matrix, and create the data frame. Okay, dates better, matrix salary new, binding with the names, my data frame as that data frame, and then I'm going to rename the columns with the call name statement. Oh, that's right, because I forgot to create the 5th variable, which is dates, and then run the call names statement. Okay, so let's take a look at my underscore data underscore frame. I have Carolina, Zoe, Cindy, John, and the date. All right. So let's open up a new R script. And I want to design a for loop for I in 1 through 4. I have 4 roommates. So I'm going to loop through all 4 variables. Okay, variables. So I'm looping through the variables, 4 roommates. And what I want to do now, so the body, what I want to do now is for every roommate, I want to get the average salary. All right, so I'm going to do this. My underscore data underscore frame. And as you guys remember, a data frame has 2 dimensions. So in my squared brackets, I need 2 elements separated by a comma. The row index on the left-hand side and the column index on the right-hand side. So on the right-hand side, I'm going to put my I index because I'm looping through the first variable, Carolina, looping through the second variable, Zoe, looping through the third variable, Cindy, and looping through the 4th variable for John. Okay, and what I want to do now is calculate the mean for each of these roommates. Okay, good. And I want to save the mean in an object called my underscore mean. Reverse arrow and the mean function, my data frame, and the ith index in my column index. I will also want to print my underscore mean just to see what the mean is for each of these roommates. Select everything, command return. Okay, so the mean for Carolina is 100,125. For Zoe, it's 62,250. For Cindy, it's 213,750. And for John, it's 33,750. Okay, that's the mean over those 4 months. Now I can improve this for loop just to take it one step further, throw in a curveball, and print the mean for the given person and the name of the person. So I'm going to create a vector. With the C function. Okay, just remember to have all the closing brackets. So I'm opening a bracket for the print statement and opening a bracket for the C function, closing it for the C function, closing it for the print function. Okay, so just remember to have all the closing parentheses in your functions. So I'm going to print my underscore mean for each person and the name from the call names. Okay, so call names, my underscore data underscore frame, but I only want the ith element. Okay, so for the first iteration of this for loop, I'll get the mean for Carolina, and this will print the name Carolina. All right, so let's take a look at how the results would look like. Command return. Okay, so the mean for Carolina was 100,125, and it also attached Carolina because call names, my underscore data underscore frame, the first column name, the first variable name was Carolina. The second variable name was Zoe, all right? So this statement with the I index is printing all of my variable names, all right? We are going into a exercise where we take 2-dimensional objects and 1-dimensional objects and use the for loop to get information based on the iteration.
Musisz tak rzucić tą piłeczkę, żeby weszła tam. No, tutaj rzuć piłkę w tamte kubeczki. Zoe. Jeszcze raz. Proszę, jeszcze raz rzuć sobie. Oj, prawie weszło. Jeszcze raz.